Now that we know what we can use to manage the glaucoma, the best thing for us to do is actually to diagnose glaucoma. And the worst thing is to treat them and leave them then in the fog, not knowing which direction they're going to go. This talk is pertained to visual field progression, and it's mainly geared towards the Humphrey visual field analysis. Just for my information, how many of the audience have an automated visual field machine in their practice? And how many have the Humphrey visual field? Octopus? Okay, so it's a good, part of the audience who have not raised their hand when it comes to automated visual field, which is an interesting. Maybe they just did not want to raise their hand. But automated visual field analysis nowadays is one of the gold standards in treatment and management of glaucoma patients. And vision has been described as a sea of vision or an island of vision in this sea of blindness. And this island of vision has boundaries, and the boundaries are, nasal, superior temporal, and inferior. It peaks at the macula, and it has a blind spot. And visual field defects, or as we call them, scotomas, are basically defects in this island, either globally allowing the island to sink, or actually holes drilled in this island, and these holes either expand over time or just keep popping up again. And this is the standard visual field printout that you would get in most of the practices. And a lot of practices, they only see this single printout of visual field, which is good to diagnose glaucoma. It's good to check for maybe new scotomas, but it's not the actual way to look for visual field progression. Because when it comes to visual field progression, you are testing points, you're testing multiple points and multiple sensitivities, and just by a glance at a visual field, you may not be able to look, and you may not even have an access to the previous visual fields, or you may have 10 visual fields. So that's not how we look at a visual field. Looking at that picture is like looking at this snapshot of a marathon. Who's going to progress here? You just have a snap. You don't know whether this guy has an amputated hand or not. You don't know whether the central guy is the fastest or not, because you just take that still picture. And if you depend on still pictures of visual fields, you're not going to be doing your patient a service. This is what is referred to the GPA summary report. And this what you should be getting when you're asking for a glaucoma follow-up. And you should not settle for less than that, because this has what you need. And I'm going to go through the types of glaucoma visual field analysis. But before that, let me just go into some of the definitions. And when it comes to glaucoma visual field progression, we're talking about either a deepening of an existing scotoma, which is the reproducible depression of a point in an existing scotoma by more than 7 decibels, or an actual enlargement of an existing scotoma, either by a point adjacent, adding more points adjacent to that scotoma, or a total new scotoma appearing in that island of vision. And either it could be a single point depression of minus 11 decibels, or a cluster of 3 points of 6 decibels. So these are the things that you just look at a glance. And if you have them, you definitely have a progression, but you should also be looking at subtle things as well. So the Humphrey Guided Progression Analysis is an advanced software module that assists the practitioners with detection of statistically significant progressive visual field loss. And it applies into the CETA standard, CETA fast, the full threshold, but it doesn't apply into the CETA swap. And nowadays, when we talk about glaucoma visual field progression, we talk either about an event progression or a trend type of analysis. So an event progression, and if you have that visual field progression analysis, you will not get these triangles. These are the triangles that you get into the analysis field. You will not get them in a single printout. You have to have a baseline. And basically, when you have these triangles into the follow-up test, and the first triangle it says that this is a new scotoma. You don't have to look for the numbers. It's all in the software. So if a scotoma pops up, it will be an empty triangle. And if it shows up into the second visual field test, it will be half filled. And if it shows into the third, then that means that this scotoma is consistent and it's reproducible and it is significant. So one of the take-home messages in here that a new scotoma is not a new scotoma until it has proven to has reproduced itself twice or 3 times. Because that is going to give you either, if it reproduces itself twice, that is a possible progression. And if it reproduced itself thrice, that is a likely progression. Of course, softwares will never tell you this is a definite progression, because then the company will be held responsible for that. But this software is a tool that will guide you not to miss progression, because if patients progressed, then they might end up into severe visual field loss or something that you might even be sued for that. So the visual field analysis, we've talked about that event analysis, and then we talk about the trend analysis. You may not sometimes highlight a single point, or you cannot sometimes find a definite scotoma. So sometimes the whole plot is plotted into the graph. It was shown in the previous presenters into the EGS graph, but you have that into your software. So the VFI plot, basically, it plots the visual field index, which is, to them, they say it's like the mean deviation weighted more into the center of the visual field, taken off the cataract effect. So it's not something that you can statistically pinpoint, but it's just a number that Zeiss came up with by taking off some of the media opacities and weighting more for central field rather than peripheral field, and they came with this number that is a percentage, and which seems to be an accurate number. So it plots the visual fields against a graph and a regression graph, and it has. We've talked earlier that there is a fixed. We've talked earlier about a fixed rate of progression, but we need to know if this progression is faster, like in this patient as a -3.7. So there are 4 types of visual field analysis. I'm just going to mention them because of the shortage of time. I'm not going to go through all of them. The GPA summary report, which is the most concise, and it will gives you the most information that you need. There is single field analysis with GPA, full glaucoma GPA report, or the GPA, the last follow-up reports. So I'm just going to go through the GPA summary report because this is what we actually look at. And in this, there are 2 baselines on the top, 2 baseline visual fields. These are the first 2 visual fields. They have to be of good quality so that you can base on them. And then after that, you have the VFI plot, and the VFI plot comes in the middle of that. With that, you have the linear regression you have the rate of linear regression, and then the last you have your current exam, and in this slide, you both have the event analysis and, sorry, the trend analysis and the event analysis. And in this point, you can see some points that are filled. That means that they have been there for the last 3 fields. Some of them have filled new ones. And there is a likelihood of progression in here. So there's a likelihood of progression. So I am going to actually skip this because that's the most important part. I'm just going to look into this and basically the deviation from baseline plot, which compares the pattern deviation of the follow-up test to the average of the pattern deviation values of the 2 baselines, which indicate changes at each test in point and decibel. So for example, a value of -6 means that the tested point was 6 decibels lower than the pattern deviation value of the same point in the baseline. And if it was 0, that means there is no change. And so these numbers, you don't have to go and pull all your graphs. You just have to ask your technicians to print them out. So I would conclude here by saying that these GPA software is available in Humphrey Visual Field machines. Your optometrist or technician should really learn how to do the GPA. The GPA analysis you need to have the reliability indices within the acceptable rate, and it must be printed in all glaucoma patients, and try to really minimize or avoid your manual compression. And with this, I would welcome my friend, my inspirer, Dr. Tariq Sharawi, to talk after me.